Okay, this is quadratic equation word problems. I wanted to work out numbers numbers 4, and 5. Numbers 2, 4, and 5 on the notes that I've given you on quadratic word problems. So that's what we're about to do. Number 2, we're going to start with, it says find two consecutive positive integers whose product is 182. Starting with the first fact that says two numbers. So we've got one number times another number. Okay. Consecutive means one right after another. It says two consecutive positive integers. So we don't know the first number. So we're going to call it x, or n, or whatever variable you want. The next number is going to be one bigger than it because it's consecutive. So these are the two numbers in order. So if it's like 2 and 3, this is 1 bigger than 2. Obviously 2 and 3 is not the answer because 2 and 3 does not multiply up to 182. So that's our goal. So we write it mathematically in a little bit different format. We write x times x plus 1 equals 182. Now you might be able to guess and check this answer and try to figure out what two numbers multiply up to 182. But this is the algebraic way to solve it. And this is the work I want to see. So we're going to take x squared, because we distribute to the other x, and then x times 1 is x. Finally, we subtract the 182 so that the right-hand side is equal to 0. This way, we can use either the quadratic formula or the or factoring. So since factoring might not be such a great method in this case, because if I knew this, I would probably already know the answer. I'm basically just guessing and checking this answer. I'm going to go ahead and dive into the quadratic formula. So we start out with x equals negative b plus or minus the square root of b squared minus 4. A is 1. C is negative 182. All over 2 times 1. That's just 2. So take your calculator, plug it in appropriately. Plug it in appropriately. You should get 729 in here. All over 2. And now we solve. So what's the square root of 729? Use your calculator to solve that. That's no big deal. 1 plus or minus 27. Negative 1 plus or minus 27 over 2. So our two possible answers, x could equal 13, because negative 1 plus 27 is 26. 26 divided by 2 is 13. Or negative 1 minus 27, negative 28 divided by 2 is negative 14. So this is our first, one of these two numbers is our first number. Take a look at our original. X could be either 13 or negative 14. But since it wants positive numbers, I'm going to take that. So the first number is 13, and the next number is 14. 13 times 14 is 182. So this is our answer to number 2. The next one's a little bit trickier. Okay, we have some geometry involved with number 4. Number 4, it says the length of a rectangular room is 3 feet more than the width. So let's draw a picture. The length of a rectangular room. Here's a room. The length is 3 feet more than the width. So here's the width. Let's just call it W. And the length is 3 feet bigger than this. So that's going to be W plus 3 more feet. The area is 154. We need to find the dimensions, so we want to know the length and the width. So let's first set up an equation. Well, we do know W times W plus 3 should equal 154. So then we solve this equation. We get W squared plus 3W minus 154 equals 0. Notice I subtracted the 154 so I could use the quadratic, so I could make it in quadratic form. Standard form, so that it equals 0. So from here we can factor or we can use the quadratic formula. Again, I'll use the quadratic formula. There's the first step. I did that kind of fast. to save some time. Here's one answer, and here's the other answer. This one doesn't make sense, and I should not have written x here. I should have written w. Negative 14 does not make sense for our variable because it's the width, so we do not accept that answer, but we do accept this as our width, so 11 is our width. Therefore, if 11 is our width, 14 must be our length. And that is what it wants. It wants the dimensions. Number 5 is another geometry problem. We've got a picture that is obviously a rectangular picture, and it is 8 by 6. Okay, this is the current dimension. These are the current dimensions. We want to reduce the length and the width by the same amount. We're just going to reduce the length and the width by the same amount. We're not going to reduce all 4 sides by the same amount. We're just going to reduce the length and the width. Now, it turns out we're going to reduce each of the dimensions by some amount. So that means we're going to reduce the dimensions. So 8 is what we start at, and then we're going to subtract some amount. We're going to reduce it by we don't know what. So we call it x. We're going to take the 6 original width and reduce it by some amount. Why did I put a multiplication problem up here? Because these two new length and widths need to multiply up to the new area will be half. So this is 48. What's half of 48? 24. So that's what the reduced photo will be. The reduced photo will have half the original area. So you foil this problem. After the first step, you should have this after foiling. And after subtracting 24 and rearranging, you should have this quadratic. Notice it is equal to 0. And at this point, you can attempt to factor or use the quadratic formula. In this case, I'm going to do my best to see how it factors. 24 So 24, two numbers that multiply up to 24 are 12 and 2. 12 and 2 add up to 14 in some way. And so this is the factorization. So we're going to take x minus 12 and x minus 2. Those two numbers do multiply up to 24. Those two numbers do add up to negative 14. So our two answers are possibly x equals 12 or x equals 2, because we set each of these equal to 0 and solve. Now, both of these answers are positive, so it is possible to take one of these numbers away from each of my dimensions. Notice, 8 is the original. I'm going to subtract some amount. I'm not going to subtract 12 from 8, because then I would not be left with any length. So this I'm going to rule out. And by ruling that out, I'm only left with one possible answer. And you can see when you subtract 2 from 8, you get 6. When you subtract 2 from 6, you get 4. So the new dimensions are 8 minus 2, which is 6, and 6 minus 2, which is 4. So 4 by 6 would give me an area of 24. However, the question asks, by what amount should he reduce the photo? So 2 is still my answer. This is the final answer. One more thought before I let you guys go is that some of you are having a hard time thinking of numbers that are consecutive odd or consecutive even. Remember, if you're an odd number, or if you're an even number, you're going to be 2n. If you're consecutive to that, if you're consecutive even, then you have to be 2 bigger. So it's going to be 2n plus 2. So these would be two numbers. This would be the first. This would be the second even number. So these are examples of consecutive even. Consecutive odd is a little different story. It's going to be 2n for 2n plus 1, because that would be 1 bigger. Notice this number fits directly in there. That's why it's odd. 2 bigger than this will be 2n plus 3. Alternatively, you could also try 2n minus 1 and 2 n plus 1. These numbers, so this is a number and this is a number. This is a number and this is a number. These sets of numbers are odd consecutive numbers. Consecutive odd numbers, consecutive even numbers. Good luck on the worksheet. We'll talk more about it tomorrow in class.